Good morning, students. Today, in the sequence of differential equation, order differential equation, linear differential equation. Last lecture we discussed about the higher order differential equation, and now we are continuing with the higher order differential equation in the form of PI. Also, I told you that the complete solution of differential equation, higher order differential equation, is CF plus PI. Here CF is complementary function and Pi is particular integral. Now we go through the continue. I explained all the method to solve CF complementary function. Here we discuss about when the root of we make the auxiliary equation and find out the root of differential equation. When the auxiliary equation gives us the root real and distinct, then the HCF is equal to C1 e to power m1x plus C2 e to power m2x. When the root are same and real, then CF is equal to C1 plus C2x e to power mx. And third one, when complex and radical term. Learning object of lecture is to know about the differential equation, to know about CF and PI. After the completion of this lecture, the student will able to determine or find out the PI. So today's objective of lecture is PI, find out the PI. And after this, some quizzes. So let's start with PI. Okay. All the best for a new topic. How to we find particular integral. Particular integral. Okay. So particular integral means that a function or a differential equation in the form of equal to q. So for CF, we make auxiliary equation from this side. But now we discuss about PI. So PI is 2x upon ft. Okay. Now there are some cases. A that first we discuss when the ft in so y is equal to 1 d minus alpha. Here we can write v minus alpha y dy minus alpha y is here p is equal to minus q is equal to so alpha dx because this is equation 1 is linear form of differential equation. Okay, so we know that in linear differential equation we find out the integrating factor, then we multiply, we write the solution with multiple y with if. So the solution becomes y dot if to x. I told you that the solution of linear differential equation of first order y dot if is equal to, here if is y e to the power minus alpha x to x e to the power minus alpha. So y x e to the power alpha x. This is the value of p. Actually, this method is called is called we have to remind this solution. Then d minus alpha, when form of d minus alpha to x, then the solution is e to the power alpha x integration qx e to the power minus alpha x. Now, if now if y is equal to d plus alpha qx, then dy plus alpha y is equal to, this is first order differential. Okay. Now, now we do if. If is equal to e to the power alpha d. So y become, now the solution. Now the solution y e to the power alpha x qx e to the power minus. So y is equal to e to the power minus alpha x qx e to the power alpha x plus c e to the power. This is the solution, and this method is called general method to find pi. We have to remind our mind the value of when we apply. When the function is tan x, sec x, cosec x, when we use this. Okay. Now some special case. to find k. Special case when qx is equal to a to power. Now, pi is equal to power. We replace d by so 1 upon if but if then we multiply with x alpha x d and again we replace d by if but for some time f dash alpha is also 0. Then we again multiply this is the solution of if if qx is e to power alpha. Okay. Now second case when qx is equal to cos alpha f. Okay, when cos alpha f sin alpha f. Now pi is equal to we make the function of this case and replace minus alpha square when if n is not इसकी वैल्यू जीरो नहीं होनी चाहिए इट मस्ट बी नॉट जीरो but but if f f minus alpha square is 0 then pi is equal to x cos multiply with cos and multiply with x and f dash d square. Again, cos alpha f sin alpha f f dash. Similarly, if f dash minus alpha square is again 0, then we again repeat the same procedure, multiply with x again to become x square and denominator f double dash minus alpha. Now third is when qx is equal to x to the power x, then if qx is equal to x to the power x, then then we make function z minus 1 minus z form and convert it to x to the power x. Okay, if the function is this form, then let pi is equal to 1 upon ft x to the power pi is equal to a by in extant form and apply and get complete field. Like for example, we take ft is equal to d minus a. Ft is equal to d minus a. Then pi is equal to d minus a x to the power. We take 1 upon a out. So this becomes x to the power m. We open this 1 upon a 1 plus t upon a plus b square upon a square plus etc. x power. So minus 1 upon a x to the power n 1 upon a and x power m minus 1 plus 1 upon a square b square where D is differential. So we get the solution and the expand d upon 18. The degree is same equal to x to the power. Now, now, now we can write this x to the power n. These are the three forms we get, and then d minus a. Here we discuss three cases when special cases then ux is equal to e to the power alpha x. Second case is ux is equal to cos alpha x and sin alpha x. And third one is x to the power n. Now we take some example of this. First we take example of this. Solve the differential. One question. We can write this as q minus d square. Now, auxiliary equation. So m square minus implies 6 am m is equal to 0. So becomes m is equal to 0. These are the roots of differential equation. Now, Cf is equal to C1 e to the power 0 C2 e to the power minus 2x plus C3 e to the power. This is the equation first. Now, is equal to 1 upon d 3 minus 3 1 plus. So we multiply these. Okay. Now अपॉन 6 और इसको हम कर देंगे, इसके इक्वली आएगा तो हम अगर लेते हैं तो लिख लेते हैं तो ये आएगा माइनस 1 अपॉन 1 प्लस एक्स स्क्वायर। नाउ 1 अपॉन 6 इसको करेंगे तो देखो 2 टाइम्स करेंगे 2x तो 2 माइनस ये सब करेंगे तो 2 प्लस 1 बाय 36 d की 4 is not required because d की 4 is become 0 plus d square or minus 2d cube. So d cube is not required, only d square. D square, so when we differentiate with it, we find 2. So we get 1 upon 60 1 plus x square plus 1 by 3 1 minus plus 80 minus 1 upon 60 1 plus x square plus 1 by 3 minus x by 3 plus minus 1 by 50 18 18 plus 18 plus 6 minus 6x. This is fine. First we do the integration also. Okay, let's solve it. 1 upon 60 this becomes 18 24 27 by 18 18 x square minus 1. So 1 upon 6 into 18 is equal to 108 and 1 upon d means 27 by d plus 18 x square by d minus 6x by d. 1 upon d means integration. Integration with respect to x. So minus plus 108 27x plus 18 x square integration x cube by 3 minus 6 x integration x square by. So 27x plus 6x cube minus 3. This is the solution of your PI. Okay. This is okay. We are in check at 27 108 27 1 upon d 18 x square. It becomes x square x cube by 3 minus x cube by 2. This becomes 6 or 3. Okay. This is the exact. Now this is the equation. Okay. Now the complete solution y is equal to CF plus CF is equal to, we have CF equation number 1 C1 plus C2 e की power 0x is equal to become 1, so C1 plus C2 e की power minus 2x plus C3 e की power 3x minus 108 27x plus this is the complete solution. Okay, students, so I explain again this method. Once we see that the question d cube y upon dx 2 minus d2y dx 2 minus 6 dy upon dx is equal to 1 plus x cube. So we can write the equation, auxiliary equation, m cube minus m square minus 6m is equal to 0. So after this we get m is equal to 0, m is equal to minus 2 or m is equal to 3, the root of auxiliary equation. Now we write CF because 3 roots are available and 3 are real and 3 are distinct. The distinct root we get, then the I know the CF is C1 e to power m1x plus C2 e to power m2x plus C3 e to power m3. Now the PI. Now we have done PI 1 upon FD and 1 plus x square. So we convert this in 1 upon 1 minus d square minus d minus upon 6 and taken above. Now expand this term 1 plus d square minus d upon 6 plus 1 upon d minus d upon 6 का square. Okay, and open till that, expand till that equal to the power of this term x square. power n. So calculate it. Now this becomes on the inside 1 plus x square. D square means 2 times differentiation of 1 plus x square. So we get 2. 1 time differentiation minus 2x. Okay. Now we solve this. After the solve the expression 1 upon d we taken inside and 1 upon d the converting integration. So we did the integration and get the complete solution of it. Okay, students, this is very good example. And now in next lecture we will do the more exercise of this type of question, and we try to find out the pi when function is cos x, sin x, tan x, and e to power alpha x, and when the function is x to power m dx and e to power alpha x dx. So v will be changed, v is also a function of x, and we will tell like that qx is equal to e to power alpha x vx. Vx here sin x, cos x, tan x, any else which are the function of x. So that function e to power alpha x sin x, e to power alpha x cos x. Then we apply another method. Okay, now we move to the quiz. I hope this lecture you understand very well. Now for the exercise and more practice you need a quiz. So I go through a quiz firstly. A complete solution each. CF part, particular integral, CF plus Pi and not. I told you when lecture starts, the higher order linear differential equation solution have two parts, CF and PA. The addition of them gives us a complete solution. Okay, so the solution is CF plus PA and PI of sin x. We have to find out the sin x PA. FT replaced by in FA when the second case, special case of second, when we discuss about cos alpha x, sin alpha x. Here he is asking about sin ax. Then I told that d square function convert in d square and d square replaced by minus alpha. Okay, so ft replaces fa. This is wrong. Find fd. This is wrong. D square replaced with minus a square. In bracket this is square. So this is the right answer because f d square is converting f minus alpha. Okay, friends. Now that general method used to find the differential equation. In general method कहाँ apply करते हैं? Where we apply the general method. So find the which part? CF, PI, CS, no. So CF, they have the method to find out the, for we find CF by changing auxiliary equation, okay, and find the root of the auxiliary equation. Then we write the CF. But in PI, when the function of 10x or without special cases, here we use, there we cannot apply special cases like qx is equal to e to power alpha x, cos alpha x, sin x, sin alpha x, x to power n. Here we apply general method. Okay, we cannot use special form of particular integral. Then we apply general method. Find the pi of cos x if fd is equal to d square. What is the value of pi? Yes. What is the value of pi? The value of pi is d square change in the minus alpha square. Here alpha is equal to e. So the pi is minus e square. Write the condition of general method. General method is condition I already told the solution maybe can say the condition or solution y is equal to we change in d minus alpha to 1 upon d minus alpha qx and write the we change in the linear equation and write the solution. If, if we take 1 upon d minus alpha, the solution we get e to power alpha x integration qx e to power minus alpha. So thank you students. I hope you understand this lecture very well and you can able to solve the problem.